Welcome to another geometry lesson. I'm so glad that you're able to join us today. I am Coach Patterson. I'm a geometry teacher at Baker High School. You caught me in the middle of a deadlift here, and one of the things that I have noticed, and we've all noticed over the last 5 to 6 weeks, is that people have become really creative in finding a way to keep up their exercise routine. Not being able to exercise at gyms or at school for high school athletes has been something that's affected a lot of people. So there's a lot of creative ideas. One, like creating this barbell out of just some household materials or things that you could find at your local home improvement store, like 2 5-gallon buckets and some concrete and a steel pipe. Now today, here's what we're going to look at. We're going to look at how would you go about finding the weight of this barbell. And we're also going to look at, if you were to change the weight of the barbell, how much concrete would you need to pour in? So here we go. This is the third geometry lesson. We have looked at several things so far. We've looked at arc length, area of a sector, and today we're going to discuss and look at volume. So let's go ahead and start with the problem here. So during the COVID-19 shutdown, people have improvised in many ways to maintain their normal routine. Jay is a high school athlete. He wanted to continue to work out at home. So here's what Jay had. He had a barbell with a 20-pound steel pipe that was also added with 2 5-gallon buckets filled with concrete. The average diameter of the bucket is 10.5 inches and the height is 14 inches. Concrete weighs 150 pounds per cubic foot. How much does the barbell weigh to the nearest tenth of a pound? Now, I want you to look at this bucket for a second. And today we're going to discuss volume. Now, volume is the amount of space that fills the inside of a solid figure, of a container. So, and we're going to talk about this more in a second. Volume is measured in cubic units. So there are, depending on what the unit is, there are cubes that take up space in this figure. And cubic units are what we measure volume in. Today, we're going to be looking at cubic inches and cubic feet. So, but if you look at this bucket, you probably notice this isn't a perfect cylinder because the bottom circle starts with a smaller diameter than this top circle. So what we're going to do is we're going to find the average diameter between that bottom circle and where the top of the concrete would be. Now, so the problem says the diameter of top circle is 11 inches, the diameter of the bottom circle is 10 inches. So to find the average diameter, okay, we are going to add 10 plus 11 and divide by 2. That gives us an average diameter of 10.5 inches, with the height of the concrete being 14 inches. Now, our essential question today is going to be, how can the volume of a cylinder be used to determine the weight of an object? Okay, our standard is to use volume formulas for cylinders, pyramids, and cones and spheres to solve problems. Specifically, we're looking at cylinders today. Okay, the materials you'll need for this project or for this problem task are a pencil, paper, and a calculator. Now, I think anytime you're solving a problem, especially a math problem, I think it is important on the front end to develop a plan before we start solving. So let's go ahead and talk about our plan today. The first thing that we're going to do is we're going to find the volume of the concrete. Okay, so the volume of the concrete including both buckets. And then one thing you notice is that all the dimensions of the concrete was in inches. But the weight for the concrete was in cubic feet. So we have a difference of units here, so we're going to have to convert from cubic inches to cubic feet. Okay, then once we've done that, we're going to calculate the weight of the concrete in the buckets, and then we'll be able to calculate the total weight for the entire barbell. Now, I wanted to include this because if you were actually doing this at home and you wanted to be really precise, there's two things that you would have to account for that we're not going to account for today. And it's this. A bucket, a 5-gallon bucket, weighs a little bit. It weighs 1 pound, 15 ounces, so approximately 2 pounds. So with two of these, you have 4 pounds there. Also, a steel pole inside of concrete is taking up some of the volume of the concrete. So when we find the volume of this cylinder, there's actually, because of this steel pole that's going through it, there's actually some volume that we would need to subtract, which would decrease the weight of the concrete. So when those weights are calculated, they're really close to being the same value. And so we're just going to say for this problem that they offset each other. But if you wanted to be really precise and do this at home, you would need to account for those two things. Okay, so the concept today, and I mentioned it earlier, is volume. Volume is the amount of space that fills up the inside of a three-dimensional figure. Now, this week you're going to be working with volume of various figures. And I know in your class this week, you're going to be looking at volume of different types of prisms. Now, a prism is a three-dimensional figure that has two congruent parallel faces that are called bases. In this problem, there's two triangles that would be called the bases. Now, the volume formula for a prism is the area of that base times the height. And the height is the distance between those two bases. Now, the reason for including this is I want you to see that the volume for a cylinder is actually the same thing. It's actually the same formula. Volume equals area base times height. You look at it though and you say, it doesn't look the same. Now, but think about this for a second. The base of a cylinder is a circle. Okay, so the area formula for a circle is pi r squared. So instead of having the area of the base, now we insert pi r squared for that. Now, step one, we're going to find the volume of this concrete. Now, again, we had an average diameter of 10.5 inches. If we cut that diameter in half, okay, that means we have a radius of 5.25 inches and a height of 14. So when we substitute those values in, here's what we get. We get pi times 5.25 squared times 14. Now, this right here will be the volume of one bucket. Now, to find the full concrete, we're multiplying that times 2. Why are we doing that? Because we have two buckets, one on each end of the barbell. Okay, so we have pi times 5.25 squared times 14, and then times 2. And this is going to be, when you punch this in your calculator, okay, the final volume of the concrete is going to be approximately 2,424.524 inches cubed. Okay, and remember, volume is always measured in cubic inches. Okay, so this will be something that you'll have to type into your calculator, and this is the volume of the concrete in the two buckets. Okay, next step. Now, I'll go back here for a second and say, okay, this is 2,424.524 inches cubed. That's in cubic inches. But remember, our weight for the concrete is in cubic feet. So we have to do a conversion here. So I just want to take our time and talk about conversions. Now, we want a conversion for cubic inches to cubic feet. But let's talk about this first. How many linear inches are in a linear foot? So a straight line foot, we know that there are 12 inches in a linear foot. A linear foot is a measurement that you can use a measuring tape for. Now, what about what we talked about last week? Last week we discussed area. What about a square foot? How many square inches are in a square foot? Now, I included this diagram here, and you can see this square. And on this square, there are 12 inches, okay, for the length, and 12 inches for the width. So how many square inches are represented here? There's 144. Okay, so there is 144 square inches in a square foot. Now, what about cubic inches? So this was 12 times 12 is 144. Cubic inches will be 12 times 12 times 12, which is 1,728 cubic inches. So you look at this visual here, and you have a cube filled of cubic units that look a lot like this. Okay, so there's 1,728 of those cubic inches in a cubic foot. Okay, so now, how do we approach this? Okay, we need to convert this volume, 2,424.524 inches cubed, into cubic feet. So we're going to use a proportion for this. Now the proportion is going to be this. Okay, we're going to start with our unit ratio. Our unit ratio is, for every 1 cubic foot, it's 1,728 cubic inches. Now, here's what we're looking for. We're looking for cubic feet. We keep the missing quantity on top because we want to be consistent. Cubic feet's on top here, so cubic feet is on top of this ratio here. Okay, and then the volume that we calculated, 2,424.524 inches cubed. So now we will cross multiply and we will get 1,728x equals 2,424.524, okay, times 1 there. We will divide both sides by 1,728. Those divide out. We divide by 1,728. And x is approximately 1.403 cubic feet. Okay, so now we have converted this to cubic feet. Next step is to find the weight of the concrete. So for step 3, calculate the weight of the concrete in the buckets. Now, so to do this, we are going to take the volume of the concrete times the weight of the concrete. Now, the volume of the concrete, we know that from the previous problem. It is 1.403 cubic feet. And we're going to multiply that times the weight of 150 pounds per cubic feet. So we multiply that. And so now we get a weight of 210.462 pounds. Now, is that the entire weight of this barbell? We have to account for the steel bar. So, step 4 is we're going to calculate the total weight of the barbell by taking the weight of the concrete plus the weight of the bar. Okay, so we take 210.462 pounds plus 20 pounds, and that produces approximately 230.5 pounds. So this barbell that we're lifting is approximately 230.5 pounds. Now, we have a second part of this problem. Jay has a teammate. His teammate, his name is Landon. And Landon wants to work out as well. He wants to stay active during this time of quarantine, but he needs a 135-pound barbell. He still uses a 20-pound steel bar. So the question is, what is the height of the concrete going to be? So how high are we going to pour the concrete so that we can create this time a 135-pound barbell instead of a 230.5? Now remember, the height last time was 14 inches. Okay, so we're going to have to work in a little bit different direction for this problem. Now, I want to go ahead and note that we're going to continue to use the average diameter of 10.5. If we were actually doing this problem, we would note that because the height of the concrete is going to be lower, then this average diameter would actually be a little bit less. For the sake of this problem, we're going to keep the same average diameter. Okay, so what we're looking for, again, is X. We're looking for the height of the concrete, okay, that we're going to pour into this bucket. Okay, so here we go. Step 1, determine the amount of concrete in one bucket. Okay, so to do that, we need to start with the weight. Now we know to find the weight of one bucket, we know that we can take the weight of the whole barbell, which is 135 pounds. We subtract the weight of the steel pipe. Okay, so when we do that, we're going to get 135 pounds minus 20 divided by 2. That is going to give us the weight of concrete for one bucket. So that weight of concrete is going to be 57.5 pounds. Now, we have the weight of the amount of concrete in one bucket. Now, from that, we need to find the height. So we're going to solve for a missing dimension. So what we need to do is we need to take the weight and find the volume from the weight. So we know that we have a weight of one bucket of 57.5 pounds. And we're looking for the volume considering that weight. Given the unit ratio, or the ratio of 150 pounds per cubic foot, this is the weight of the concrete. So we have set up another proportion. We are going to cross multiply with this proportion to solve for the volume of this bucket. Okay, so we cross multiply here. 150 times x is 150x. 57.5 times 1 is 57.5. We'll divide both sides by 150. Okay, now, when we do this, we get x is equal to 0.383 repeating feet cubed. Now, I want you to think about this for a second. This is in cubic feet, but our height needs to be in inches. So we have to convert again, and this time we're going to convert from cubic feet to cubic inches. Okay, so we want to know for 0.383 repeating cubic feet, how many cubic inches is that? So we have our unit ratio here, that 1 cubic foot is equal to 1,728 inches cubed. Okay, so now this will convert our volume to cubic inches. So we have 1 times x is x, and then 1,728 times 0.383 repeating, and that produces the volume of 662.4 inches cubed. So now we have the volume of this bucket as 662.4 inches cubed. So the last step in this is going to be to find the height from the volume. So, using volume formula, determine the height. Okay, so we know the volume formula, that is, volume equals pi r squared times h. For this problem, we know the volume. Our volume is 662.4 inches cubed. So now our goal is to solve for h. So 662.4 inches cubed equals pi. times 5.25 squared times h. .25 squared is 27.5625. So we have pi times 27.5625 times h. So the next thing that we're going to do is we're going to divide both sides by pi times 27.5625. Those divide out, and we divide this by, I'm going to put this in a quantity here, pi times 27.5625. Okay, so we have 662.4 divided by pi times 27.5625, and rounded to the nearest tenth, h is approximately 7.6 inches. Okay, so to recap what that means is for Landon's 135-pound barbell, for Landon's 135-pound barbell, it is going to have a height of concrete of 7.6 inches. So I have enjoyed being with you today. This was a problem context that I really enjoyed because it allowed for me to creatively approach a situation that we all find ourselves in. We all find ourselves in a situation where we want to exercise, but again, gyms are closed. So we can take something that is very real world to us, like building this out of things you can find at a home improvement store, and now we're able to calculate the volume for that as well as the weight, how much it weighs. So again, I've enjoyed being with you today. Have a great day.